Welcome everyone. This lecture is in continuation with the previous lecture, and now we shall briefly discuss the historical development of the electronics. The first known electronic devices were the vacuum tube devices, and the simplest vacuum tube device known was the diode. And the diode is also called the diode valve. Why valve? Because it passes the current in only one direction. Just like a water valve which passes the water in one direction, a diode is supposed to pass the current in only one direction. This will be more clear when we will study the PN junction diode characteristics in subsequent sessions. Okay. So, diode was invented by John Fleming in 1904, and by making some modifications in diode, De Forest invented the triode in 1907. As of now, all these vacuum tube technologies are obsolete. By obsolete, we mean that we no longer use these devices in our modern day circuits. In our modern day circuits, we use the semiconductor diode and transistors and other devices made of the semiconductor technology, but not the vacuum tube devices. So, we will very briefly discuss the working of these devices with the help of these circuits, and just to make our historical introduction complete. Okay, now let us examine the working of diode. This is the leftmost circuit is the diode valve, and in a diode valve you can see there is a cathode and there is an anode, and the plate is called anode, and we have provided the positive potential on the anode, on the plate, with the help of plate supply. And the cathode is a filament which emits the electrons, and this is due to the effect which is called the thermionic emission. In the thermionic emission, the emission of electrons from heated, the thermionic emission is the emission of electrons from heated source. So when the filament supply is given to the filament, the heating effect of electricity take place, and I square RT heat is generated, and with that heat some electrons are emitted, just like the boiling of water. We can understand the thermionic emission just like the boiling of water. Whenever we boil the water at a particular temperature, the water molecules leaves the surface of water and convert into the vapor. So just like this, the electrons are emitted at a particular temperature. Whenever there is sufficient amount of energy in form of heat is provided to the electrons of the cathode, or the whatever metal is used in the cathode. So at that temperature it emits the electrons, and those electrons are attracted by the positive potential of the plate. You can see the plate is having the positive potential because we have applied the positive voltage at the plate or anode. This is also called the anode. And when the electrons are attracted, then the circuit completes, and the current, a plate current, is flows in the direction of arrow. As we know, the conventional current flows in the opposite direction of the flow of electron. So this is how a diode valve used to work. And here you can see the triode. The working is same. The modification is this: we have introduced one more electrode which is called the grid, and we have applied a negative potential on the grid. Here you can see the input signal. Again, we have applied a negative potential of the grid. uh, we have applied negative potential on the grid, and we have applied the positive potential on the plate. Again you can see the positive plate supply is the positive terminal of the battery is positive terminal of the battery is connected to the plate anode, and here you can see the grid. The grid is the grid is given the negative potential with the help of input signal, and again there is a cathode, and the cathode is supposed to is supposed to emit the electrons. And you can see the working is same whenever the filament supply is given. Then the filament heated filament emit the electrons, and those electrons are attracted by the plate, and now we can control the amount of electron which are reaching at the plate by changing the grid potential. If we are applying some negative grid potential here, if we are then you can see the grid potential will repel the electrons, as we know by the basic electrostatics. Excuse me. Same kind of charges attract each other, same kind of charges repel each other, and the different kind of charges attract each other. Okay, so here you can see with the help of this graph we can analyze the situation. Okay, now we can see the changes in the characteristics. Now look at the 100 volt. The plate potential is 100 volt fixed, but you can see at a different grid potential, when the grid potential is 0 volt, the characteristics is the uppermost characteristics, and when the grid potential is -2, the characteristics is different. When the grid potential is -4, it is different. And you can see the decrement in the current. The decrement in the current is due to the grid potential, because some of the electrons get repelled by the negative potential of the grid, and by this we can control the amount of current.